Welcome back, everybody. This is the homework review for Lesson 38, volume of truncated cones. And a truncated cone really is like a regular cone that has the tip of the cone cut off. So you're separating a smaller cone from the larger cone, and the leftover piece is the stump, if you will, would be the truncated part. And so just keep in mind that we're going to be eventually find the volume. We're really doing big volume minus small volume. And so in our first question, this is again the homework review for part 1. There'll be other parts afterwards. For the cup for the dimensions shown, do the following. Set up and solve an equation find the volume x shown in a diagram. And so what happens is this. We have really two right triangles. The first right triangle is going to be, in this case, this large right triangle here. And so the height of this right triangle will be the x plus 20, and the base will be 6. We also have the smaller part. This is the part that's going to be cut off. Smaller right triangle, whose height will be x and whose base will be 4.5. And they're similar to each other, and we know corresponding sides of similar triangles are proportional. So we'll create a proportion here. The length or the height of the large right triangle over its base, which is 6, so x plus 20 over 6, is equal to x over 4.5. Now we're going to cross multiply. And so we cross multiply, we're going to get 4.5 times x plus 20 is equal to 6x. Or we should be, we get 4.5x. Now 20 times 4.5 will be 90. Now we can take away 4.5x from both sides. And we get 90 is equal to 1.5x. Well, if you divide both sides by 1.5, we're going to get x equal to 60. Okay, x equal to 60. So that's our first part. We actually found a value in this case. So the value of x is going to be 60. Now that means that your original height of the big cone is 80, because 60 plus 20 is 80, while the height of the small cone will be 60. So we're going to find now the volume of the truncated cone equals the value of the big cone minus the value of the small cone. And so the volume of the big cone is 1/3 times pi times the radius, which is 6, squared times the height, which is 80. So really it's like the same as the volume of a cylinder, but 1/3 though. And we talked about that last time before with volumes of cones. And so now the volume of the small cone is going to be 1/3 pi times, in this case, we found the radius to be 4.5, so 4.5 squared times 60. And so the difference, the volume of the truncated cone, is going to be, now notice that they both have 1/3 pi. So what we're going to do is we're going to factor out that 1/3 pi. So it's really 1/3 pi, and what's left over is going to be 6 squared times 80 minus, because we're subtracting the two of them, 4.5 squared times 60. Now we want to find the nearest cubic centimeter. So nearest cubic centimeter, we're going to use a calculator for this, okay? Let's break out the calculator. Let's clear some things here, okay? And so we will have 1 divided by 3 pi. Now the calculator knows to do 1 divided by 3, then times pi. So don't worry about that, okay? And parenthesis, 6 squared times 80, because that's the radius squared times the height, minus 4.5 squared times 60. Close, oops, no, not that. We need to put close parenthesis. And so this is going to what we have here. And now the calculator tells us that our volume is about 1,743.58. But we're rounding to the nearest cubic centimeter, so it's a whole number. We're rounding to 1,744. So it's about 1,744 cubic centimeters. Okay? All right, so the idea is, and then you could have, let me just close the parentheses here to make sure we have that though, okay? That you could have, factored out the 1/3 pi. You didn't have to. You could have 1/3 pi 6 squared times 80, then minus 1/3 pi times 4.5 squared times 60, and then we get the same exact answer. Okay, so this is going to be the volume of this truncated cone here. Okay, all right. Now, we use this method for our second question. Our second question, a small plastic vessel has the shape of a truncated cone as shown. The cubic centimeter is the same as a millimeter. So we're going to need this later on. So milliliter, so cubic centimeter is the same as a milliliter because we're going to find our volume to the nearest milliliter. So, we'll find our volume normally though, okay? And again, this measurement here is going to be 10, making this measurement here to be x plus 10. All right, the radius here is going to be, well, because it's half of 6.4, we see it to be 3.2. So that's really going to be the base of the large rectangle, while the radius here, or that base of the small rectangle, will be half of 4.8, which is 2.4 centimeters. And just like before, because they're both right triangles, the corresponding sides are in proportion to each other. So we will write a proportion. We have the height of the large cone or large right triangle, x plus 10 over the base or its radius, 3.2, is equal to x over 2.4. And we'll cross multiply. We get 2.4 times x plus 10 is equal to 3.2x. And we're going to get 2.4x plus 24 equals 3.2x. Subtracting 2.4x on both sides, we're going to get 24 is equal to 0.8x, dividing both sides by 0.8, x equals 30. So this is a big value for us, because now we're using this value of 30, we know that this measurement here is going to be 40 centimeters, and this measurement here is going to be 30 centimeters. And just like before, the volume of the truncated cone is equal to the volume of the big cone minus the volume of the small cone. And so the volume of the big cone is going to be 1/3 pi. Our radius is 3.2 squared, and our height is going to be 30 plus 10 or 40. The volume of the small cone is 1/3 pi. That's going to be 2.4 squared times 30. And therefore, the volume of the truncated cone, is equal to, again, we'll factor out the 1/3 pi. This is left to right. So 1/3 pi, parenthesis, 3.2 squared times 40, minus, because we're subtracting here, minus, okay, so minus 2.4 squared times 30. We'll close that. And now again, we'll break our calculator. So 1/3, so again, we do 1 divided by 3 pi, parenthesis, we're going to have, in this case, 3.2 squared minus 3.2 squared, but we had to remember to multiply that by the height of 40, minus 2.4 squared, the radius of the smaller cone, which is the base of the triangle, small triangle we had, times the height of the small triangle, which is the same as the height of the cone, small cone, times 30. Close that parenthesis. And now this volume will be equal to 247.976. Now, we round this to the nearest tenth, we're still going to get, in this case, 248. Nearest whole cubic centimeter will be 248. All right, and so here we'll get, in this case, 248 cubic centimeters. But we want milliliters, but the milliliter is equal to the same as 1 cubic centimeter. So the same as 248 milliliters. And so this is going to be the answer we have here. Very important number we'll need for our next question, because the next question, number 3, references question number 2. And so there are 16 liquid measuring cups in a gallon. And if a gallon contains 3,785 milliliters, and there are 16 cups, what they want to know is the vessel we had equivalent to more or less than the liquid measuring cup? So we take this 3,785 and divide by 16. Okay, so let's take that number, 3,785, divide that by 16, and we get, in this case, 236 milliliters. Well, 237. So it's about 237 milliliters. Now, the vessel from question number 2, we found this volume to be 248 milliliters. So this is the measuring cup. And this is going to be the vessel, the plastic vessel we found. And so the question is the vessel more or less than a measuring cup? It's close to it, definitely close to it. So our response would be the following. The vessel from question number 2 has a greater capacity than a measuring cup, liquid measuring cup. Okay, and that's it. So what we have to do is just kind of compare the two. So they were related to each other, very related to each other. So our vessel is going to be slightly larger than a liquid measuring cup that we found null. So yeah, so that was all there was to it null. But the key thing was, of course, find the volume of the vessel null, or the truncated cup, if you will. It was not a cup as a measuring cup, but more on the lines of, was close to it though, measurement-wise. This will be the end of part 1. I hope this was helpful to you guys. You see in this case that we use the same technique of similar triangles to help us find the volume of the truncated cone. And so yeah, it seems like a kind of a messy type thing, but this is a great question. Great question, ladies and gentlemen. Make sure you go over these questions and all, and the similar triangle setup and all, and finding the volume of the large cone, and then find the volume of the small cone, and subtracting them to find the volume of the truncated cone. So hope it was helpful to you guys. Leave any questions or comments below. We'd love to hear feedback from you guys. Appreciate it greatly as you watch the video. If you found it helpful, please give it a like. And if you have not subscribed to the channel yet, please do so and turn on notifications to know when new videos are coming up, especially since this is the last topic we're doing on geometry. And so any new videos will probably be going into Algebra 2. So, you want to know when those are coming though. Okay? Thanks so much, ladies and gentlemen. Please take care, be safe. I will see you in the next video.